Okay, welcome back. We're going to spend some time going over fiber cabling, F-I-B-E-R, before we go back to the fiber channel protocol, which is F-I-B-R-E. So I gave each of you a fiber cable, and you can just open it up here. On your fiber cable, you will have two strands of glass, which is the fiber optic cable itself. And because light only travels in one direction, you're going to have one strand that processes light signals in one direction and the other in the opposite direction. Okay, so for this particular diagram here, on the left-hand side is going to be your transmit, and on the left-hand side is going to be your receive. For traffic in the opposite direction, you're going to have your transmit here, and then your receive over here, your RX over here. Good? Now, all of these fiber strands have an inner diameter. And if you take a look at your cable closely, it should be listed there as 50/125 or 62.5/125. Do you guys see that value there?
Yeah, I can read that as well.
That first value is the inner diameter. So this is 50 right here. Okay? This last value is the diameter of the outside cladding. So you're going to have cladding. Let me get another color here. On the outside, like that. I'm not going to do this for the other strand. So this is your cladding. And that's, this value here of 125 is the diameter of that cladding. Okay, good? So two sizes that are typically used. There are other cable sizes, but these are the two sizes that are predominantly used in your data center, 50/125 and 62.5/125. Now these cables can also come in different modes, multi-mode or single mode. In multi-mode fiber, you are using a red LED laser that's in the visible spectrum, but still fairly high powered and enough to affect your eyesight. Okay, so don't be looking directly right at the cable like this, saying, "Hey, is there red? I can't see it." We have testers in the lab that basically connect to this, and then it shines through a lens, and the lens disperses the laser signal, so you can clearly see whether or not light is coming through one of these strands. Okay, but please don't be just looking at it directly. In multi-mode fiber, you can use multiple frequencies. simultaneously. Okay, so I can send a signal down this line here, like that, on one frequency, F1. I can send another signal down here, F2, and because they are different frequencies, they will never interfere with each other. Okay? That's what we mean by multi-mode fiber. You can send multiple frequencies of light through here, and those signals will not interfere with each other because they are different frequencies. In single mode, you only have one light signal at one frequency being sent down the line. So in this case here, it'll just be one particular light signal, and it tends to bounce less off the walls of the boundary between the actual fiber and the cladding. So this glass here is right against this boundary layer with the cladding, and that effectively causes this here to this edge here to be a mirror. Okay? And that's why the light is able to just bounce down one direction. Okay? That cladding is very important to ensuring that that light signal reflects back into the actual strand of fiber. Any questions on this so far? Pretty straightforward. When you are in the data center, what you typically will do is you will have a server, and you will have an HBA, and on that HBA will be a port for this connector, and this connector is called an SFP. Small form factor pluggable. That's what SFP stands for. No need to memorize the acronym, just know it's called an SFP. You guys can look it up later on. So within one SFP, you're going to have two strands, one for light in one direction, light in the other direction. You're going to connect this cable. You can either directly connect it to the port on the target, in this case the array or switch, or if you encounter an issue where your cable is not long enough, or you need to go from one location to another, what's going to happen in most data centers is that you will have patch panels and the patch panels are connected to each other by a cable bundle of multiple strands of fiber. So there will be a panel here, for example, labeled rack 1, panel 2. Over here, you can have rack 5, panel 1. And between these panels will be a big bundle of multiple strands of fiber, and then the individual combinations of two strands, right? One for light in one direction, one for in the other direction, that are going to be connected onto the panel. And then they will be labeled port number 1, port number 1. Everyone good? So at this point, you then set up your server that's going to have an HBA. You connect the SFP to that port on the patch panel. You look up in the documentation in the data center where that patch panel goes to. So there will be documentation here that R1 patch panel 2 goes to rack 5 patch panel 1. So you go over to rack 5 patch panel 1, find port number 1, and then you connect your cable to the storage. So you need one cable here and one cable over here. This inter-panel bundle is fixed infrastructure. You never go in and move it once it's been installed. So you may have to have multiple jumps within the data center depending on where your equipment is installed before you finally connect the initiator port to the target port. That make sense? Mm-hmm. Yes?
Are patch panels part of the systems that we're selling to customers, or do they have their own?
No, that's their infrastructure.
Okay.
Yeah, within their data center. Now, there is a scenario here in terms of patch panels that can cause intermittent problems in the customer's environment. And that's going to be when the customer accidentally or unknowingly intermixes these sizes. Okay? So you can get into a scenario where you have on the left-hand side 62.5, and on the right-hand side you have 50/125. And so it looks like this. Now 50 is going to be a smaller diameter. So when it abuts against this particular fiber cable, it's going to be a wee bit smaller. That makes sense? Because the inner diameter is smaller. So what happens, remember this is light signal, so one of these has to be transmit, one has to be receive, one has to be transmit, one has to be receive. So let's look at the condition where light goes in this direction. You're good to go. You send a slightly different frequency of a signal through the line. Let me see what other colors do I have here? And some light escapes. That make sense? In the opposite direction, light goes this way, and because the cable diameter on the left-hand side is larger, it fully captures all of the light. And the customer calls you up and says, we're having intermittent problems. You go in, you look at it, sure enough, you're seeing errors being logged at the port and at the driver level, right? Remember what happens when you lose a frame? What happens to the sequences and the exchanges? They get canceled and then redriven. And any intermittent frames that have been either damaged or does not arrive, they get redriven as net new frames. That make sense? Mm-hmm. So in your environment now, you're having exchange and sequence errors. At the port, you're seeing framing errors, and you start replacing components. You replace the HBA, you replace the firmware. You upgrade the firmware, you downgrade the firmware. You replace the server, replace the cable, and then you keep doing that again for a couple months. Okay? And the problem continues to exist. It's like a low-grade fever, right? It's not enough to cause major issues, but it's enough that you can observe that a problem is existing in your infrastructure, and it drives you nuts, right? And then someone comes online and says, Mr. Customer, could there be a chance that you just recently moved to a new data center? And the customer's like, oh yes, 6 months ago we just moved data centers. Like, really? Okay. Did you have net new cabling, or did you somehow bring existing cabling from your prior data center? So he's like, I don't know. He goes, okay, well, I need you to check the size of your cabling end to end in terms of the size. And usually what happens is in older data centers, they're using the larger cable. And in the majority of newer data centers now, the trunk lines here between the panels are going to be 50/125. Okay? So just be aware of that scenario can occur. And that's really all you need to know in terms of fiber, F-I-B-E-R. Any questions? Pretty straightforward. We'll go downstairs later on, maybe this afternoon or tomorrow, and I'll show you that. Learning the patch panel nomenclature in the lab is difficult. Okay? The original vendor that put it in didn't do a very good job. Okay? And it's a very convoluted methodology that they implemented. So you kind of have to look at it, squint your eyes a couple times, go patch panel to patch panel, squint your eyes a couple times, and say,
At least labeled.
it's labeled accurately. You just have to squint. You can read the labels, yeah. Sometimes it gets so bad that what we do is we shine the laser and then we go to the patch panel with the detector. Do you see the light? Do you see the light? Like, oh, there it is. Disconnect it, turn it off. Reconnect it, turns on. Disconnect it, you do it a couple, 3 times, and you're like, okay, that's the port.
Is there like an industry standard for labeling all that stuff?
There is, but
No one follows.
different cabling vendors will cable it in a slightly different manner. No 2 data centers will be the same. So. Everyone good with this here?
Especially
Okay.
if you have an infrastructure vendor that comes in and wires up your new office in your new data center. Oh yeah, they're going to be following that standard. That's a part of their contract. If they don't, they're going to relabel.
Okay.
I paid them to do it.
Okay. So, if you recall yesterday, when we went over fiber channel, you said that every single initiator and target in the environment has an HBA. This is fiber channel, and it has a 64-bit worldwide name associated with it. And that these HBAs can then be connected to switches within the infrastructure, and specifically fiber channel switches, not IP switches. So let's go back a bit in terms of these fiber channel switches. If you have a bunch of fiber channel switches in your environment, so in this case we'll put a couple here. Like that. When you turn on these switches, the first thing that these switches do is they identify a principal switch.
Is that like spanning tree root switch?
Similar, it's going to be the principal switch by default is going to be the switch with the lowest worldwide name. Okay?
Just like MAC addresses and STD.
So lowest worldwide name wins. However, in most environments, what you typically want to do is that the storage vendor should make one of these explicitly the principal switch. Okay, you can either be lazy about it and have the algorithm figure it out, or be proactive and say, you know what, in all scenarios, I want this guy to be the principal switch. Now, if you recall, the FCID was a 24-bit value. You guys remember that? And that the FCID is split up into 3 parts. And you have 8 bits here, 8 bits here, and 8 bits here. No need to rote memorize this, guys. If you show propensity for fiber channel connectivity, we'll send you to the training. Okay, no problem. So you have a total of 24 bits, and the first 8 bits here are for your domain. Whoop. And then the switch, and then the port. Okay?
The domain is user set.
The domain is the first, the domain ID is determined by the principal switch.
So that's not something that you can set for multiple domains in your own data center?
You can set it based by controlling who the principal switch is.
Okay, so it's hashed
The
out.
pro- Correct. You then connect, so for example, in this particular environment here, let's say this domain is domain number domain 5. So in here you would have, what's 5 in binary? Come on guys, quickly.
Zero.
So it's 1, 0.
1 0
Zero, one.
1
Yeah, 1, 0, 1.
1 0 1, like that. Good. You guys did good. It's 8 bits, right? So 0 0 0 0. There you go. And then fiber in fiber channel, the protocol that's always running in every single switch is going to execute to make sure that there are no loops in the environment. So the first thing this guy does, you know, if this guy here had the lowest worldwide name, or he was the principal switch, is he starts sending out notifications to everyone. By the way, I'm the principal switch. Okay? Just to tell everyone, announce to everyone that I am the guy on the network. Okay? The role of the principal switch is that he's going to maintain a DB here of the routing table. And this database is then going to be propagated out to every single switch so that every single switch has their own independent copy. As changes are made to this database based on who gets plugged into the environment, those databases then get, those database entries get propagated out to all the other switches within the same domain using link state notifications. Don't worry too much about all the technical things. Just be aware that every single switch, right? Fabric shortest path first, protocol is running, and it's basically saying, hey, I see this new node here, propagate it out to every single switch. I see him on my port. Now you can see here that on in the FCID, you have a field here for the switch. So this guy here is going to be switch number 1. First switch. You then plug in S2 into fiber channel switch 2 to fiber channel switch 1 via port 5 and port 6 over here. they will update their databases saying, hey, my port 5 on fiber channel switch 1 is connected to port 6 on fiber channel switch 2. And that entry gets propagated through the whole environment. Remember that fiber channel shortest path first, FSPF, is running all the time, and it's sending out these updates, and it is running with class 1 priority. Fiber channel data flows by default run with class 3 priority. So even if you have a bundle of data frames, fiber channel data frames, filling up the buffer here, being queued up to be sent across the link, and you get an SFPF link change notification, who's going to take priority? Link change over your data. This is to ensure that at any given time, every single switch knows the connection to the other switch and which is the lowest cost link between the switches. And by default, they only use the lowest cost path. Right? So over here, for example, for this particular switch, FC dash S3, they're connected to S1 via port 1 and 5 here, and port 6 and port 3. Now, switch 3 has a connection to switch 2 via port 6 to port 3 on S2, and he's directly connected. Switch 3 is also connected via port 5 to switch 1, which in turn is connected to switch 2 via port 5 on port 6, which is the lowest cost path, the one here. So this is the path that's going to be favored for transferring data between those two switches. Can the switch use the alternate path? Sure, but why would you do that? This is how, in fiber channel, it's able to ensure that there are no loops, that frames just don't go around and round, by only favoring the lowest cost path and making sure that these databases between the switches are updated constantly using a class 1 priority update method. Supersedes the flow of data traffic. So then, on every single switch port, you have the port number. So over here, you have port 6. So if I were to connect this HBA over here to port number 2, my expected FCID associated here would be, entry would be domain 5, switch 1, port number 2. Convert this to binary, and that's what you would see in binary.
Colons, or do they use dots like some things?
For what? For
that FCID?
it's typically just a hexadecimal value that's given to you.
Just a large string
Yep.
instead of dotted up or coloned up?
No, it's just one hexadecimal value.
Okay.
But that's the format of it right there. So based on the FCID alone, you can identify the domain, the switch, and the port where that worldwide name was seen. So now this particular FCID is going to be associated in the database with worldwide name 1. That's going to be in the database. And the database is again propagated out to every single switch. So now when a fiber channel frame comes in, so over here, you have a target and you have a worldwide name 2 for the HPA. There's going to be an associated FCID for this worldwide name. That's absolutely unique based on the domain, the switch, and the port. You should never get any two FCIDs that conflict with each other in fiber channel. Should never exist. So now when the fiber channel frame is put on the wire, your FC frame, is going to have a source FC worldwide name and a destination FC worldwide name. The moment this particular fiber channel frame hits this port, the switch takes a look at the destination FC worldwide name. He has a copy of the database from switch number 2. Looks up the worldwide name and says, oh, your FCID is this value. The FCID tells it exactly how to route it because the FCID identifies the domain, the switch, and the port. And the switch puts it on the link that has the shortest path to the destination. Any intermediate switches perform the exact same task. Here's the frame, look it up. Here's your worldwide name, this is your FCID. In the FCID, oh, you are at switch number 2. Lowest cost path to switch number 2 is via this path. Shove the frame out that lowest cost path. And it repeats that over and over again until it arrives at the destination. Any questions on that? All of this to tell you, okay, that fiber channel fabrics are very stable. That's what you need to learn from this. They are very stable environments. Tends to be very difficult to mess up fiber channel, but customers do.
That's what I knew it was doing.
How would they mess it up? They put in switches with the exact same domain IDs, right? And remember that the domain ID has to be unique, right? And so the fabric segments. Basically, the ports that connect the two switches that have the same domain ID say, we can't talk to each other. But FSPF basically says something's wrong, not allowed, bam, separates them. It's called a segmentation. Now, was that segmentation caused by a fiber channel? Yeah, the protocol did it, but it's segmented because someone did something wrong. Crazy, like manipulating the domain IDs, and right? They were trying to be smart, manipulating the numbers themselves. Questions on this?
Is there anything that has a class 2?
There are some customers that use class 2 in general. For most implementations, it's always class 3. Very, 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 very few. And even then, for those environments, we usually ask them, why? You good here? Okay. So let's go through this process again in terms of F-loggy. You have a host on one side. You have a fiber channel switch and then a target. Each of these HBAs has a unique worldwide name. The moment you connect the cable, connecting the host to the fiber channel switch, every single one of these HBAs is going to F-log E. The result of that F-log E is there will be a unique FCID generated associated with that worldwide name. Customers having connectivity problems, first thing I do, go into the switch, verify that the FCIDs are being generated. If I don't see the FCIDs, you better verify that that link exists. Once the FCIDs are generated and F-log E is successful, we hope that there is a management configuration here called a zone. And in that zone, there is a definition saying that worldwide name 1 is allowed to communicate with worldwide name 2. So within the switch, the fiber channel switch, you need to have zones defined. A net new switch from the factory will have what's called a default zone, meaning all ports are allowed, all worldwide names are allowed to see each other within the fabric.
Zone 1 by default?
It,
Just a,
default zone.
this is what it's called.
Default zone, yeah, for all vendors. Not good. Okay, not good.
Overwriting eventually.
You could, if you have a host that is very aggressive in how it searches for disks, it can take down a system. So you want to have zones defined. So in this case here, we have a zone defined. And then you put that zone into an active zone set. So you can have multiple zones defined, but only the zones defined in the active zone set are effective.
A lot of customers who just assume it's like an unmanaged switch, like
Yes.
a 4-port switch. You just plug it in and not worry about it.
Yes.
Do that.
And you'd be surprised at who the vendors are that do this, because some of them can be very large companies. Is there a pause option in the recording?
Yeah.
There isn't? But I can mute myself, right? Okay, so there are. I'm giving you an example of a large company
Yeah.
has a lot of power, a lot of engineering resources behind them, yet still may not fully grasp some of the technical requirements that need to be in place for their environment to be stable. And they will make this argument in front of you out loud in a conference call, 20 people, and they will say, we do not need to do this. I'm sorry, Mr. Customer, the specifications are the way they are. Right.
I don't know if you guys have seen the flame icon.
So, let's see here. Any questions on? Okay, so after this, you then you have floggy.
I just want to make sure I got my wording here correctly. So the recommendation is to create a single zone for a single host, single machine.
Yeah. Yeah. At that point, the environment, the initiator is going to ploggy into the environment. And once you have a ploggy, you're going to have a virtual SCSI bus created. SCSI bus created, at which point the initiator can put in CDBs, and the CDBs pop out here. Pretty straightforward. This is what you guys need to picture in your mind in terms of the processes that need to take place for successful connection between initiator and target, regardless of vendor. Now, if you're like, Paul, this is not detailed enough for me, I want more, you can go talk to Dave Rakers. And this is the more detailed login process that you sometimes have to troubleshoot for the more difficult problems. Okay? So this is, can I rotate this?
Yes.
There it is. Okay? You guys see that? You can see that between floggy and ploggy, there are a host of other interactions that have to successfully occur for ploggy to be to function properly. Okay, so I'm giving you a brief overview, giving you the fundamentals of what you need to learn, understanding that should you want to get more into connectivity, you will then have to learn about all of these other processes and troubleshooting methodologies. But really, that process of floggy, ploggy, that's all I've needed to learn for me to be successful in helping customers troubleshoot their environments. When you have problems here at this level with RCS ID, you're now talking most likely about a code bug, right? Identifying a code bug. That's way past what I want to do in terms of fiber channel, right? So I leave that to my colleagues in the connectivity group to learn these details. Fair? Okay. It is now 12:08, lunchtime. Any questions on fiber channel before we continue with TCP/IP in the afternoon? Everyone is allowed to skip out on the TCP/IP module, on the networking module. Who here has taken a formal class in Ethernet networking and IP networking before? two of you guys? Okay. If I ask you guys to explain to me what is a subnet mask and what is it used for in IP networking, can you explain that to me? Aaron, Craig? No? Okay.
Nothing close to formal.
Okay. Okay. So we will not skip that module then. Not in excruciating detail. We'll be spending maybe 4 to 6 hours on TCP/IP, and again, I'm teaching you the foundational information so that you can you are conversational on it with the customer. If you want to learn more about networking, specifically IP networking, we teach a CCNA data center class here within here in San Diego. In addition to that, you have access to the Cisco CCNA courses. In addition to that, you have Tony sitting next to you here who just passed a CCNA that you can reference. In addition to that, we have the whole CCNA, CCNP, and CCIE stack downstairs for you to play on. Okay? So again, this comes down to what are you really interested in terms of where you want to be in your career. All the gear is here for you. Okay? I think, did you log into the systems downstairs, Tony? And
The only reason I did it is because I still don't have the admin account in order to be able to install like eating putty and stuff.
okay, okay.
Yeah.
Oh, on your laptop, you mean?
Correct.
Oh, gotcha.
But it doesn't need
Okay.
it then, but we don't have our dual access accounts yet.
Okay.
I've got mine, but it's not active yet.
Not
So-
for that.
So if you're not aware of what are dual accounts, it used to be the case that GSC had an agreement with IT that we would have full administrative access to our laptops because our roles in terms of troubleshooting customer problems many times requires us to install software on our laptops that may not be on the allowed list for IT. Okay? Over the past year and a half, IT security has cracked down on pretty much all our systems to ensure that we are not at risk to many of the threats out there. Okay? Now that has an adverse effect on us because we need to be able to install tools that allow us to effectively troubleshoot things. So a middle ground was reached where IT said, okay, we can create dual accounts for you. So for me, my regular login is P Nationalis. You can request for a dual account, which is your NT login name with an X at the end of it. So for me, it'd be P Nationalis X. You then fill out the appropriate form with IT, and then IT will enable that administrative account. And that administrative account, P Nationalis X, can then be placed into the local administrative group on your laptop. So that should you need to install some sort of third-party software, it will then prompt you for administrative access. You submit your P Nationalis X account or your X account, at which point that software can then be installed. Okay, so I don't know if you guys already have your dual account set up. If not, make sure you get that done through IT. Any other questions on fiber channel?
What's the most amount of zones that you've seen?
Zones that I've seen, I've never really counted.
Like on the order of thousands?
No, probably in the low hundreds.
Okay.
In the low hundreds.
I would imagine there's a limit.
There is. It's very high though, and it's just the only reason why it's in the hundreds is because again customers are lazy, in the sense of creating single initiator, single target zones is administratively high. The cost is high. So you almost need someone who has the scripting skills, right, or the processes in place, so that the moment a new device is installed in your environment, you get the worldwide name of the initiator, worldwide name of the target, you put it into some sort of process, and it automatically disseminates the zone information and then puts it into the active zone set. When you're only dealing with a few zones, it's fairly easy to manage. When you're dealing with thousands of systems, you need to have an almost automated process of installing and enabling those devices in your environment. Very few customers, truth be told, have those things in place. Much of it is still being maintained via regular Excel spreadsheets. Okay.